Python is an object-oriented programming language, which means it allows programmers to create objects that encapsulate data and functionality together. Understanding classes and objects is essential for writing efficient and organized Python code. Class is a blueprint or template for creating objects. It defines a set of attributes and methods that the instantiated objects will have. An object is an instance of a class. It is a real-world entity that has properties or attributes and behaviors, also known as methods. When creating a class, the class name should follow the Pascal case naming convention, which means that each word is capitalized and with no underscores. And the class body should contain method definitions and variables. So when we're defining our class, we use the class keyword followed by the name of the class that we want to create. So for now, just get a basic name of class name. And here, remember, we want to have capitalized letters for each word. And we do not want to include any underscores or anything like that. So we want to use this convention. Then we use a colon, and under that, this is going to be our class body, basically. And here we're going to be defining our class methods and variables. And of course, when we want to create an empty class, we use the pass keyword to use it as a placeholder so that we can create an empty class. But of course, we will build onto this in just a second. Now, each class has a init method or initialization method. The init method is a special method which is also called a constructor. It is automatically invoked when a new instance of the class is created. It initializes the object's attributes. So with our class called class name, we would define a init method, which is basically 2 underscores and then the word init, and then another 2 underscores, and then parentheses with the parameter self. And if we want any additional parameters, then we could add the parameters here as well. And then our colon, and this is where we would initialize our code. And the class body, of course, goes here. The self in the self argument refers to the instance of the class. It is used to access the class attributes and methods. We will get into this in just a bit. Now let's try creating a real example. So let's create a new cell here and let's create a class called person. And in that class, we're going to have our initialization method with our self parameter, and we're going to provide 2 more parameters called name and age. And this is going to basically reassign our parameters to the self parameters. So here we have a person class which has an init method that initializes the name and age attributes. Now, if we want to create an object, then we will have a completely new line here. And let's say we create an instance called person1. And we're going to use the constructor to create that instance now. And so we're going to use the class person followed by the 2 parameters that we have defined here, which were name and age. And that is what we're going to be passing into the constructor. So let's say our name is going to be Alice and the age is going to be 30. And we could run this. And now we have an instance of the class person. And we could actually check this by doing print type person1. And when we run this, we can see that this is the type of this class. So this person one is of type of the person class. Now, this instance has its own attributes, which are going to be the name and age. And we passed into the constructor the name and age, and these specific values are going to be assigned to this specific instance. And we could check that by doing print person one.age and print person one.name. And then when we run this, we have 30 and Alice. So this specific instance has a predefined name and age, which we assigned through this constructor. And we could do even another example here. Copy this and let's create a new code cell, paste this, and we're going to call this person 2, and it's going to be John. And we're going to say age 20. And similarly, like we did here, we can copy this and paste this here, change this to person 2, and this to person 2 as well. And when we run this, person 2 has these specific values that we assigned, which were the age of 20 and the name of John. So each instance is going to have its own pre-assigned attributes. And this is why the self argument is important here, because it is a reference to the instance that we have created. Otherwise, we would have not been able to distinguish one from another. So this self basically refers to the instance that we have created and the values that that instance has defined, or basically the attributes that we have defined for that specific instance. Now, classes can have instance variables and class variables. Instance variables are defined within methods, are unique to each instance, and prefixed with the self. Class variables are defined within the class but outside any methods and are shared among all instances of the class. So let's create a new example with a new class, and let's create a new code cell, and we're called the class employee. And in that class, we're going to have company name, and that's going to be, for example, Tech Corp. Now this is going to be our class variable. And then we will define our initialization method, our init, for self, and we're going to give it a name. And we're going to assign that name to the instance name. And so now we can create 2 employee instances. So emp1 for employee 1, it's going to be employee, and we're going to call him Bob. And then we're going to have employee 2, it's going to be employee, and we're going to give the name Carl. And now when we print employee 1 and the company name, oops, copy that, and employee 2 company name, when we print that, they both have the same company name, because this is a class variable, so each instance that is created by this class shares this variable. But similarly, as we did before, when we assign the name to the specific instance and we try to print that, then of course each instance has their own employee name. So these are instance variables which are specific to each instance, but these are class variables, so they're accessed through all the same instances, or all the different instances. And if we go back here and we do print, or actually no, before we print, of course, let's change that class variable, so employee dot company name. That's how we access that variable. And we're going to assign it new tech. And let's copy this. And we're going to do company name again, just to be sure. And when we run this, both of these instances have the new company name assigned, which is new text. So changing the value of this variable impacts all instances that are created. Classes also have methods, and methods are functions defined inside a class that describe the behaviors of an object. So let's create a new example, and we're going to create a class called circle. And in that circle, we're going to have pi, which equals 3.1416. And we're going to have our initialization method, our self argument, and we'll provide the radius. And we're going to assign that radius to the instance or the radius that belongs to that instance. Then we're going to define our method. And our method here is going to be calculating the area of the circle. So we're going to call this method area. And similarly to the init method, we're going to also provide the self argument. And this self argument refers to the instance that is calling this method. And we're just going to leave that self there, colon, and we're going to return circle.pi. So we're getting the value of pi, which is from the circle class. So we're getting that variable times self.radius. And so we're referring to the radius that was defined for that specific circle. And then we square it. And so when we create a circle instance or an object, we use the circle constructor, and we're going to define the radius as 5. And so we could print circle, not the big one, but the little one, circle 1, except this is misspelled, of course. Circle 1 dot radius. And once we run this, we get a small error. And my mistake, we kind of didn't finish creating the init method. I forgot the underscore here. Now everything looks okay. So let's try running this again. And of course we get our radius 5. And if we do circle.1 and then the area, called the area. So this instance is calling the method that is defined in that class. And when we click play, we get this radius. And of course, if we change this, let's create a new cell, not markdown, but new cell. And we're going to call circle 2. And we're going to give this a radius of 10, or let's make it 20. And we do circle to that area to calculate the area. And then we click play. And then we get a completely different area. So, if we run this again, circle 1 has this area, and then circle 2 has this area. So each instance is calling its own area method and is referring to its own radius that was defined for each instance. You can also modify an object's attributes directly, or you can use methods to do that. So if we go back to our circle example, let's add a set radius method, and we have our self argument, and we're going to provide also the radius as well. And we're going to change, or basically set the radius using this method. Now we have two options. The first option, like I mentioned before, when we create our circle 1, we could then change the value of the radius for that instance by directly providing that new value. So using the dot notation, we could access the radius. So circle 1 dot radius, and actually let's print this out just to show you that it's 5, of course, just like we defined it here. Then we could change this by either directly assigning a new value. So we could do circle down 1 dot radius equals, say, 25. And then if we print it again, so circle 1 dot radius, shift enter, then we have 25. So the new value that is assigned to the radius for this instance now becomes 25. Another possible option is using it through a method. So here we earlier defined a set radius method. So we could do circle 1 dot set radius, and then we could provide the radius as 35. And if we print circle 1 dot radius, then we get 35. So we could either directly assign the new value to that attribute, or we could use a method to assign that as well. Python classes can use encapsulation, which is the concept of bundling data and methods within a class and restricting direct access to some of these objects' components. And some of these restricted components are what we would call also private attributes. And in Python, private attributes are indicated by prefixing the attribute name with an underscore, a single underscore, or a double underscore. The single underscore suggests that the variable is intended for internal use only, but the double underscore triggers the name mangling to prevent accidental access. So the single underscore is going to be only assigned for future developers or anyone else that wants to use the code, that it shouldn't be used outside, but double underscore, if that is attempted to be used, then that is going to throw some kind of error. So let's create a new example here, and let's create a bank account class where we're going to keep track of our balance. So let's create our class. It's going to be our bank account. Then we're going to have our init method. And here we're going to be initializing the balance. And then here we're going to be assigning the balance. And here we're going to try to do a double underscore, making it that it is a private attribute so that it cannot be used outside of the class. So we're going to have double underscore balance, and we're going to assign the balance to this private variable. Then we're going to have a new method, which is going to be our deposit, which is what we're going to be using for depositing our balance into our balance. And we're going to provide the amount. And we're going to be adding that to the balance. And then we're going to have a get balance method to see what's our balance and how much money we have in our bank account. So we're going to have a def get balance. And we're going to also provide the self argument, and we're going to return the self.that underscore balance variable. Now, we're going to create our instance or object, which is going to be our account from our bank account. And we're going to provide an initial balance of, let's say 1,000. Then we're going to deposit, let's say $500. And then we want to check what is our balance. So we would use the get balance, count get balance, and we want to be able to see our balance. And when we run this, we can see our balance of 1,500. But if we were to try to access it directly, so count dot underscore balance, and we try to run this, then of course we get an error that the object has no attribute because it is a private attribute. But if we change it to a single underscore, and let's run this again, this is okay. And then when we run this again, remove that one underscore, then it prints out the 1,500. So with a double underscore, it throws an error that we cannot access that variable directly. But with a single underscore, we do not have that error. So the single underscore is only to suggest that it shouldn't be accessed outside of the class, but a double underscore will definitely provide an error. Now, the reason that I cannot access this directly using the direct access method, so let's switch this back to double underscores. Let's run this, and let's run this again. We get this error and we cannot access it. And the reason we cannot access it is because when we put a double underscore, it actually changes the name of this variable to underscore class name. So the class name would be bank account. And oops, I meant single underscore. So on that, there we go. So the class changes the private name from underscore balance to underscore class name double underscore balance. And it does this so that nobody could accidentally access this or overwrite this when trying to access directly using that name. So this way it prevents users from easily accessing this variable. And the reason that we could access it through a method is because this automatically is part of the class logic inside here, and we don't have to worry about changing the name of the private variable because it automatically does that inside the class. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.